So number 5 on the Unit 9 test review is a solve for x problem. And the first thing you want to do on number 5 here is you want to get rid of this square root. And the easiest way to get rid of the square root is to square both sides. And when you square both sides, you end up with x minus 4 squared equals x minus 2. Of course, you know that when you square this entire side over here, that means that you have to FOIL that entire side out. So I like to get rid of that squared, and I like to actually write x minus 4 times x minus 4 equals x minus 2, just to remind myself that I need to FOIL that out. And when you FOIL that out, you've got x squared minus 8x plus 16 equals x minus 2. And hopefully you recognize that as a quadratic because of the squared term. In order to solve a quadratic, you need to get a 0 on one of the two sides. I'm going to propose that we subtract the x and add the 2 to both sides. That'll leave us with x squared. We subtract the x, you got minus 9x. Add the 2, you got plus 18 equals 0. At this point, you can solve that quadratic a few different ways. You can use the quadratic formula, you can graph it, see where it crosses the x-axis, or you can do what most of you are going to do, which is factor it. When you factor it, you've got x minus 6 times x minus 3 equals 0, which means that the two solutions are x equals 6 and 3, but we need to check them to make sure they both work by plugging them in. 6 minus 4 is 2. 6 minus 2 is 4. The square root of 4 is 2. 2 equals 2. X equals 6 is a solution. It checks. And 3, we need to double check that one. 3 minus 4 is negative 1. 3 minus 2 is positive 1. The square root of positive 1 is positive 1. 1 does not equal negative 1, which means that 3 is an extraneous solution. There's only one here. It's x equals 6. When you plug it in, 3 minus 2 is positive 1. 3 minus 4 is negative 1. 3 minus 4 is not negative 1. Square root of 1 is 1. That's negative 1 equals 1. It's wrong. Okay, so that's number 5. The next one I want to do is number 10. And on this one, rewrite in exponential form. On the test, when it says rewrite, it simply means to write the exponent up there and then distribute the exponent. If it says rewrite and extract all the roots, that means you need to simplify it as well. But since it just says rewrite, you don't need to do any sort of simplification. You just need to realize that a cube root is the same as raising the whole thing to the 1/3 power. So I'm going to rewrite this as 27 times y to the 5th times z to the 3rd to the 1/3 power. 1/2 power because it's a square root. It's live TV, everyone. Thank you. 1/2. So we'll want to distribute that square root, or sorry, that 1/2 power. And when we do that, we'll get 27 to the 1/2 power times y to the 5/2 power times z to the 3/2 power. Because 5 times 1/2 is 5/2, 3 times 1/2 is 3/2. And you can just keep it just like that. Now if it said extract all the roots, then you want to do something with this 5/2 and that 3/2. But it didn't ask us to do that, but it will ask us to do that on a later problem. Well, the next one is number 16. And on number 16, it says, restrict the domain of the function x plus 1 squared minus 3 so that its inverse is a function. Well, if I was going to make a rough sketch of this thing, I know it's a parabola. I know that it's gone left 1, up or down 3, because plus 1 means left 1, minus 3 means down 3. So I know that this thing kind of looks like this. And I know that when I take the inverse of that thing, when I reflect it across the line y equals x, it's going to be this sideways looking thing that's not a function. So what we need to do is split that quadratic right in half. And if we split it right in half, then the inverse will be a function. So I'm going to simply restrict the domain of this first one by splitting it right in half. So the real question is, what's that x value? that cuts that quadratic right in half. You can get it from the equation. This says left 1. So that means that this line right here must be x equals -1. So I simply want to restrict the domain to be x is greater than or equal to -1, or you could restrict it as x is less than or equal to -1. And that will split that quadratic right in half. Either of those two answers will work, and then the function, the inverse will be a function. So that's number 16. The next one I want to do is number 24. Which I'm having a little trouble finding. And number 24 on the test review says simplify and write in radical form. So we've got this thing here. The easiest way, and I think the only way really to simplify this thing, is to rewrite it in exponential form and then try to manipulate the exponents somehow. So I'm going to simply rewrite this as 2 times x to the 4/6 power, because remember the exponent goes on top and the index goes on the bottom of the fraction. So index on the bottom, exponent on top. And then I've got square root of 36, of course, is just 6. So I'm going to just rewrite that as 6. And then I've got x to the 1/2 power, because remember a square root is a 1/2. Now at this point, we're going to divide the numbers and we're going to subtract the exponents. So 2/6 is the same as 1/3. And then we're going to have x. And now up in that exponent, we're going to do 4/6 minus 1/2. Now if we want to reduce that, we're going to need to find the common denominator. So I'll say that's equal to x to the 4/6 minus 3/6. And of course, 4/6 minus 3/6 is just 1/6. So that's 1/3 x to the 1/6 power. But we're told to rewrite it in radical form. So I need to realize at this point that the 1/6 power is the same as taking the 6th root. So I'm going to rewrite that as 1/3 times the 6th root of x. That's the final answer there. The next one I'm going to do is number 25. And that one is a word problem. So I'll read it. The time it takes a pendulum to complete one full swing is given by the radical function time as a function of length equals 2 pi square root of length divided by 16, where t is the time in seconds and L is the length of the pendulum in meters. To the nearest tenth of a second, how long does it take a pendulum to complete one full swing if its length is 1.2 meters? So I want t of the length that they give me is 1.2. That's going to equal 2 pi times the square root of the length that they gave me, which is 1.2, divided by 16. Now the only thing tricky about this is typing it in the calculator. So I want to show you exactly how I would type this in the calculator. I would type in 2 pi times the square root of 1.2 divided by 16, close those parentheses, and then you just hit enter. And you end up with this thing. And we'll just go ahead and round that to 1.72. So when the length of the pendulum is 1.2 meters, the length, the time that it takes to complete one full swing is simply 1.72 seconds. And you'll definitely want to put your units on that. Since it's a word problem, we usually want to put our units on there to get the answer. The last one that I'm going to do here is number 26, which is also a word problem. And number 26 says, in medicine, the body surface area, BSA, is used to help determine proper dosage for medications. The equation BSA equals the square root of W times H divided by 60 models the relationship between BSA in square meters, the patient's weight in kilograms, the patient's height in centimeters. Determine the height to the nearest tenth of a centimeter of a patient who weighs 60 kilograms and has a BSA of 1.75. So I'm going to use the equation that I have, and I'm going to plug in what I know. The BSA that I'm given is 1.75. I'm going to set that equal to this fraction with the 60 in the denominator. I'm given the weight of 60, but I don't know the height. So I'm solving for the height. The first thing we ought to do is multiply both sides by 60. So 1.75 times 60, that's 105. And I want to get rid of that square root next. So I'm going to square both sides. 105 squared is 11,025. And that equals 60h. So to get that h by itself, the last thing you need to do here is divide both sides by 60. So 11,025 divided by 60, that is 183.75 centimeters, but they said to the nearest tenth of a centimeter. So I want to make that 183.8 centimeters. And that'd be your final answer there.